Okay, we are back to, again, this is a part 2 in a series. However, I am still dealing with arithmetic sequences. I know, my writing is terrible, but you know I meant sequences there. Now, to start out with, what we talked about in video 1 was that we had the terms where A is the term, N is the number in the sequence, like the first term, or the second term, or the third term, and so forth. Okay, so now, and we also talked about the explicit form, where this will equal an expression with N in it. Okay, so this equals an expression where N is the variable. All right, so if it's the first term, I would plug 1 in and I would get an answer, and that would be my first term. I could plug 20 in and get the 20th term. What's interesting is that because that is also the explicit form, we can write it as a function. So you could also write this as a function where N is the variable. So remember, in function notation, the function is the result. We put it into some sort of formula or expression with N being the variable, and we get a result. All right, how in the world do we do this? How does this work? Because you could also write that, obviously, where X is involved, and that should look a little familiar. So let's think about this. What if we have the sequence this time of 11, 4, -3, -10? The question becomes, is this arithmetic? If it is arithmetic, there will be what we call a common difference. So let's see, what's the difference between 11 and 4? How much does this, in this sense it goes down, so it's a negative rather than a positive. It goes down by 7. So if I add -7 to 11, I'll get 4. Does that hold? If I have 4 plus -7, do I get -3? Yep. Does it continue to hold? Yes, it does. So this is called -7. In this case, D is the common difference. So now the question becomes, how do I work this into a formula? Remember what we said, the common difference, because we're repeatedly adding as we go up in the terms. So when I write anything, guess what? It's going to be -7 and then whatever variable I'm working with. So if I consider the f of x format, or the function format for this explicit form, I would have -7x. Okay, the only problem is, if I consider the first term, and this is what you have to kind of figure out. So if I'm looking at the first term, that would be -7 times 1. Okay, wait, -7 times 1. Does that give us 11? No, it doesn't, right? There's something in between there. -7 plus something will give me 11. What do I have to do to get 11 from here? Well, obviously, maybe not obviously, but if you were going to solve an equation, you would add 7 to both sides, if you can picture that. So if I had let's see, I'll put it over here. If I have -7 plus some unknown, I'll call it B, equals 11. How would I solve that? I would add 7 to both sides. So B would equal 18. So we'll just do that off to the side. Okay? So obviously, if I add 18 here, that makes sense, doesn't it? If I have -7 plus 18, by golly, that gives me 11. So this is called the explicit form. So I have to remember to go back up here and add 18. So when you're asked for the explicit form, that's when you can just plug the number in and go, and you get whatever term you want. That can be given in this form, a sub n, where I'm defining the term, okay? And I can have the -7n plus 18 for this particular example. Or I can write it as f of n to get negative 7n plus 18. All right, or I could write it as f of x equals negative 7x plus 18. In any case, these are all the explicit form of an arithmetic sequence, and not surprisingly, the reason it's in this unit, this is for my son, where he's learning it, these are all linear equations, which is interesting. Thank you.